So what am I saying? I am talking about the second derivatives. The second derivatives, because we've been able to see the first derivative, and then from there we are able to solve whatever we want to solve. But now we want to make a step forward, and that is the second derivative. Second derivative. Now the second derivative, third derivative, fourth derivative, and all that, we call them all further derivative. And then, like I told you, there are reasons, there are some advantages of the second derivatives, because it is from this second derivative that will in let's say in respect to curves, with this second derivative we will be able to determine the stationary points. We will be able to discern or determine the stationary point, whether it is a minimum value, a minimum point, or a maximum point. The second derivative will teach us that. I do remember when we were in the secondary school, we were given some problem, quadratic functions to plot, but the funny part of it then was that because we didn't have sound knowledge of the subject, we were at guesswork. Did you know that somebody had to plot a graph that should be N shape, and then what he gave us was a U shape? That's the, you see, he just plotted it and gave us a U shape. But we that are naive of the whole thing, you see, there's nothing we could do. Everybody jumped at it, and of course, the outcome of it. Yeah. So, but with this differentiation now, it becomes a lot easier. It becomes a lot easier for you to, identify your stationary point. Because we find that at stationary point, y dx is equal to 0. At stationary point, then this, like I told you, the stationary point could be a maximum point or a minimum point. Then for us to discern which is which, we introduce further derivatives. With further derivative, otherwise the squared y over the x squared will not tell us whether that is a minimum value or a maximum value. If it is a maximum value, something will show us that. If it is a minimum point, something will show us that too. And from there, we will now be in better position to position our curve so that whoever, even the examiner, will be, rest assured that we know what we are doing. You see? But there's one thing, this good news. You don't need to plot your graph. For those of you that are writing your WAEC, for those of you that are writing, NECO exams, because I know that graph is a number, it's a must. It's in there. Students run away from that, but it's very, very simple, very, very simple. If you have this idea of differentiation, you bet me, as soon as the question papers are served to you people, you rush down to graph. Within a short period of time, you are done with graph and collect the whole marks. The whole marks. Yes. So, like I was saying, the further derivative will teach us whether it is a maximum point or a minimum a minimum point. If it's a minimum point, then we'll find out that our a will be greater than 0, so that we have a minimum point. When our a is less than 0, we'll be having a maximum point. So what are we trying to say? You have an N shape, that represents a maximum value, and then a U-shaped curve when we have a minimum value. Yes, a minimum value. That is the way it is.